And also there might be people still walking around trying to find us. Who knows? No one has contacted me, so I'm not expecting it. But hi, my name's Sam. Like I said a little bit earlier, we're doing this workshop. So what is this workshop that we're doing? We're here to learn about different pieces of the data lifecycle, which is why I created this whole thing. So we started in Q1 with, oh, look at that. We started in Q1 with data engineering. So we did data engineering January, February, and March. We covered some of the different pieces of data engineering, like orchestration, containers like Docker, container systems, and what do we talk about? Data modeling also in the data engineering quarter. Now we're in the data analytics quarter. So data analytics quarter, we're going to focus on what do we even do? Like, what is data analysis? Why do we do data analysis? Like, we're going to work with like real examples of it too, so you can like actually see what I mean. I have a couple of slides here where we'll talk about it, but this way you can actually see what we mean when we talk about data analytics. It'll help if you have some Python and maybe some SQL experience, but if you don't, no problems. Like, you'll be able to get all the stuff done just fine. We do have a GitHub also, so if you don't have experience with GitHub, it's a great time to learn while you're doing this with us. I just pushed some code to the Git right before I left. So there is code too if you're in the Discord, and if you received the welcome email because you signed up on the Google form, then I have your GitHub username and I've added you. If you haven't done the Google form, then I don't have your GitHub username and you haven't been added. That's how you get added. But everyone in here that has done that should be added to that GitHub, and you should have that code. So there is code already on the Git, and we'll walk through it a little bit later. Today we're just using Google Colab, so you don't have to install Python. You don't have to have anything with Python on your machine. Also, we do work along, so if you have a machine, great to work along. Wanted to remove, last quarter we dealt with some dependency stuff and some installing package stuff, so we're not going to do that. We're just going to use Colab. We're trying to start really easy, and then everything we do will be DuckDB, which is just a way in Python that you can use SQL. So we're using Python to execute the code, but everything, all the logic and everything we do will be in SQL. So all you really need is SQL. The Python I'll give to you. You don't really have to worry about it. So that's that. Yeah, any students who are about to graduate who are on the job hunt, please raise your hand if you're looking for a job and about to graduate. We have one over here. You want to introduce yourself?
Yeah, sure. I'm my second year fintech student here.
Okay.
My name is Haley. Came from a math background, and right now I'm studying financial technology.
You said your name's Haley? Yes. Okay. Second year fintech student, came from a math background, looking for a job. Right. Okay. And for the recording too, I'll get you in front. No, I'm just kidding. But good. Let's connect on LinkedIn and let's see what we can get going for you too. I definitely want to help as much as I can, and if anyone else in here can help, that would be great too. But we'll do this when it's student focused like this. I'll do this, the students raise your hand thing. If there's a lot more professionals, what I like to do is who's looking for a job and who's hiring, and have people kind of go around and talk and say what they can do and what they're interested in, and then also for people who are hiring, say what they're hiring for. Also, that provokes a question. What are you looking to do?
Actually, in finance.
Okay.
Looking for like risk analyst and like market risk and quantitative analysis.
Okay, so like quant work, risk analyst work in finance, staying in finance. Okay, awesome. Good career. So where are you? Pretty much everything I just told you, but you're in the full stack data workshop. We did the first 3 sessions last quarter. These are the next 3 sessions. Each quarter is a different focus. The idea here is to follow the data lifecycle. So data engineering is really the beginning of where data comes from and how we get it from outside to inside. And so that's the beginning of data lifecycle. We started with that. And then now we're in data analytics, which is, okay, now we have the data. What do we even do with the data? What do people in the business want from the data, et cetera, et cetera. So the next one will be data science, Q3. That's August, September, October. No, sorry, July. I don't know the quarters. July, August, September is data science, in ML ops and governance. And then just like a play thing in December is going to be October, November, December. Months. Okay. Data engineering and recovering data scientist. That's who I am. I'm also Sam. So thinker and doer, went to NC State, sorry. Fails fast, wins fast, patient about democratizing education, all these fun things. I just like this, and I wanted this when I graduated grad school. And so this is really where the idea for these whole workshops came from. And I hope you can pull something out of it, right? Whether there's 5 people or 50 people here, I just want the people who are here to enjoy being here I know you're spending time. Time's the most important thing for me, so I think it's the most important thing for you. So I'm not going to waste your time, and we're going to have fun. We're going to learn some stuff, and we're going to go ahead and do it. So what is data analysis? So the process of inspecting, cleaning, transforming, and modeling raw data with the goal of discovering useful information, blah, 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 blah. But that's essentially what it is. Okay, what does that actually mean? So why is it important? So it's crucial in today's data-driven world, ChatGPT said. Helps businesses optimize their performances, make informed decisions, solve problems, understand trends, patterns, or predict future outcomes, and we go on and on. But really, it's just how can we take this like infinite wealth of knowledge that we have available to us, whether it's on the internet or stored in our proprietary systems and databases, how do we take that and actually learn something from it? And then why is it important? If we can learn something from it, we can make money off of it. That's why it matters. We're not in research positions anymore in grad school. Now we're working in the business where really everything you do comes down to how much money can I make off of it, or how much money can it save me from spending it in other places. So that way I can make more money by spending money. So data, and everyone in the organization does that. Data analyst just does it in a different way. So what does the data analyst do? Responsible for being someone that can talk to both data and business people is really what I wanted to get out of this. This is obviously not written by ChatGPT. I wrote that. But really the translating role. Data analyst is heavily a translating role between here's the numbers on the computer, here's the information that we have, here's the things that we're doing, and then some guy over there in product or in marketing or girl, hello, needs to know how can I make money? What product is going to be good for me next quarter or 2 quarters from now? They have questions about the business. They understand the business. They don't understand the data. You understand the data, and you lean on them to understand the business, right? So you're the translator between the data and the numbers and the business being able to make money or understand the business more. So who is the business? Let's pull off this mask of who is the business. So think about a business partner, someone you've had before, someone I've had before. Product owners can be a business partner. So these people are responsible for moving the business forward via innovation through the means of like new product lines or new products. Product owners are really responsible for, well, that's a product owner. You could have an innovator, you could have a product manager, there's a lot of different product people, but product really is what's a new thing we can do that we haven't done before, or how can we make the things we're doing better? And they have questions around that, and they want to maybe even launch new products. And when they want to launch new products, you're going to have to answer a lot of questions around like, is there even a market demand for this? And that's what the data analyst does. The data analyst really evaluates, is there a demand for this thing, or could there be a demand for this thing? Maybe we haven't done it before, but we've done similar things, or our competitors have done similar things. Let's buy their data, let's get it in, and then let's analyze their data, right? So you can also buy a bunch of people's data. So my own examples of working with the business. So I worked with finance in one of my first roles. Actually, this whole thing is one role. Analyzing P&L sheets, helping finance build predictions for different product lines, right? So they wanted to understand like this product line versus this product line. Kind of had the same focus, but the target audiences were different. They wanted to understand like which target audience would be more effective to reach out to, right? And so we were doing different predictions and different models on the product lines for finance. P&L. Then product, where were these markets or opportunities that we could take advantage of? So the product and marketing had a lot to do with each other in this sense. Product would want to launch a new product, but then marketing would have to market that new product or else it wouldn't be successful. So they're working really hand in hand. So a lot of these projects went together where I was working with both product and marketing. But the marketing could be split out a little bit further. So on the bottom, you see PPPC, and PPC is just cost per paid click, I think is what it's called. I got the acronym super wrong on that, but cost per paid click, cost per click. Marketing was really into the different ways that they were reaching their consumers and reaching their people, and were they paying too much to reach the right people? Were they paying too much to reach the wrong people? And we're doing a lot of analyzing of who's clicking and why are they clicking, and did they actually go buy something then? It was a lot of customer journey work that we were working on. So this is my example of working with the business. I've kind of flown up till now. Yeah, I definitely want to. Yeah. No, you're good. I want people to talk and yeah.
Isn't this definition you're referring to as a data analyst role?
Yeah, yeah.
What's the difference in your mind with a data scientist? Or do you think that data scientist is just a buzzword? That's my question.
Yes. No, I'm just kidding. data scientists have to be able to do data analyst work, right? It's just you have to extend the data analyst extends their skill set, becomes a data scientist, right? So the base is like data analytics and being a good data analyst. You can't be a good data scientist without being a good data analyst. Because as a data scientist, you might not have an analyst on your team and you might have to do all that work yourself before you can then go build the model. We don't have like the liberty of just knowing everything and then building the model off of it, right? We have to like go find the things out and then use the knowledge to go build the model, if that helps. But data scientists definitely do a lot of data analyst work. Like most data scientists, between 50 and 70% of their work, I feel like, is just data engineering and data analytics. Like the data science work is really like XGBoost. Nice. Move on. like deep learning model. Yeah.
I think that's nowadays the opinion of everyone, probably.
Yeah. It like data scientist is the sexiest job of the 21st century, right? Like,
maybe it's not anymore.
Yeah. Now it's data engineering. Now data engineering is the sexiest job of the 21st century. I don't know, Zoe, I mean, in your experience, right? Like,
yeah, I'm definitely doing the data engineering right now.
Yeah.
Data analyst. We don't have an analyst on the team, and yeah, I might get to XGBoost one of these days.
Yeah, maybe. Like one a month.
Yeah, linear regression is more of a speed.
Yeah. Especially when you get into like interpretability, right? And then because the business wants to know why things happen, they don't like most of the time, unless you're working in someone who's like with a team that really just wants to make more money and they don't really care why. Like most people care why, right? Because they need to know like how to make decisions based on things. They're using you as the data scientist to say, okay, like the statistical analysis said this, the evaluation said this, and you're going to make this much money. Okay, that doesn't help me. Like, how am I going to make that much money? And then you have to dive down. Okay, this coefficient weight was the largest, so this makes me think that's like the biggest factor. The model says that's the biggest factor of why you're going to make more money, and then how, right? Derive like a whole plan around that. So it's not just like XGBoost, yeah. Even though we have Lime and Shapley, but like business doesn't believe in. You start inventing things like that, they're like, even though it's not invented, it's real, but you start bringing stuff up that they don't understand.
It's probably harder to understand how Shapley works than understanding how XGBoost works. So
Yeah.
Every time one needs to go back to the paper to understand how to use that. So it's
Right.
true, you have some explainability, but every time it's not the explainability they want. It's not really to use. That's my opinion.
It's not anything that they saw in school, so they don't trust it.
Yeah, I think that's a better issue.
They learned linear regression back in like 9th grade stats class, so like they could reason back and be like, okay, that's like that makes sense, you know, like cool. But that's it. Like Shapley is like you need a math major, hey, to understand what Shapley is, right? So, yes, data scientists, just glorified data analysts, glorified data engineers, kind of packaged into one, and then 15% of that is like actually doing cool modeling work. So becoming a data analyst is really like your stepping stone, right, to becoming a data scientist, if that's how you want to look at it. Or you could just say, okay, I'm going to go become a data scientist, but you still have to be able to do all this stuff to be a good data scientist. You can't just be a data scientist unless you want to work like in a university and then just work with CSVs all the time. That's like the only way I think you could just be a data scientist and not be a data analyst. That was a good conversation. Anyone have questions about any of this? Like the working with the business thing? We'll do more of that later. Great. The importance of data analyst in the business. So there were a couple slides earlier. I had, hello. Good evening. No, you're fine. A couple slides earlier, I had why is data analyst important in the business, right? Something like this. Roles and responsibility. Why is data analyst important? Okay, so this one's similar, but this one I wrote myself, so kind of copied and paste. Analysts are incredibly important for an organization. They have ability to bring new product lines forward with the help of the product manager or also stop them. But you're going to need a lot of validation to say like, hey, don't do that. And then you have to validate like why you're saying don't do that. But you really do have a lot of power as an analyst to say, yes, you have a real opportunity here, or no, you don't have an opportunity here. And then a note on the bottom is just sidebar about the politics of being in data, because if you get into one of these fights about like, no, you shouldn't do that, you're probably going to lose. Actually, like 99% of the time, you will lose that fight. Sometimes you might actually choose to keep going down that rabbit hole, and that's fine. Most of the time, our job is just to say, hey, this is my recommendation, this is my analysis, this is what I think is going to happen based on the data, based on the evaluation, analysis, et cetera, et cetera. I think this is going to happen. I recommend either you continue forward or stop. And they're going to go, cool, and then they're going to do the opposite of what you just told them to do. But it's fine. You did your job. You got your paycheck next Friday, so you're good to go. But, you know, there's a lot of politics here when you said, okay, you asked me to do this work, I did this work, and you just completely ignored it, right? Because you went with what you wanted to do anyway. It's important also of making your work visible. So when something goes wrong, it's not your fault. Importance of data analyst in the business continued. So analysts can build dashboards, make predictions, not usually, and then run statistical hypothesis tests when needed to validate populations for a possible new product launch. Really on the product vibe today. When it comes to data analysis, I excel. I like that meme. But this one, so building dashboards is definitely huge as an analyst because there's a part of making your work visible that the business really needs to understand. Like they need to know the work you did. They need to be able to like digest it in an easy to understand way. So you'll always be building dashboards. And the best thing you can do for yourself is build the dashboard with the business partner, not just like delivering it after you've built the dashboard. Best thing you can do is like iteration 1, like, what do you think about this? Iteration 2, what do you think about this? Iteration 3, what do you think about that? And like build it with them so they have input, so they feel part of the process. Otherwise, your dashboard's getting sent to the dashboard graveyard, and it will never be looked at because it doesn't show what they want the way they want it to show it. And if it doesn't show the thing that they want to see in the way they want to see it, they're never going to use it because they don't fully comprehend what's going on or how to understand it. Even if you created 17 pages of documentation for how to read the dashboard, which is a bad dashboard because it shouldn't need that much documentation, but I did that once, it still got sent to the dashboard graveyard because I didn't involve the business partner. The next time I involved the business partner, it became one of the most used dashboards at the organization because the business actually understood what was going on because they were part of the process of building the dashboard. So you'll get stuck building dashboards, but there's ways to make building a dashboard an actually enjoyable process and not something that sucks and is draining and makes you want to quit, which you can quit too, but you could also just fix the problem, not run away. And then you can make predictions. Sometimes you do throw up like a exponential smoothing model or do something simple in Excel, right? And you've got like a simple prediction. You can start with that. It could be like your base prediction before you move into like an ARIMA X model, or if the data scientist moves into the ARIMA X and you're the analyst and you built this exponential smoothing model, it's really simple prediction model in Excel, and yours is better than the data scientist, you can call BS in the data scientist work and say, look at this is better. And then statistical hypothesis test is probably one of the most important pieces. Yeah? Can you explain what's dashboards? Dashboards. Yeah, great question. So dashboard would be like the Tableau or Power BI. Do you know Tableau or Power BI? Yeah, so it'd be like Tableau or Power BI of metrics, of put whatever metrics you want into this visual aid that a business partner can look at, and they can pick it apart and they can filter it by different filters. It's really business dependent what a dashboard is going to be. But usually it's a way for the business partner to evaluate different KPIs and different metrics in a visually pleasing way, right? So a KPI might be, if we go back to this marketing example, cost per paid click or cost per click in a marketing organization, you might be measuring that by day, by month, by region, or by product line. And you have different ways you can slice and dice like those metrics, because then you want to make sure you have ROI based on your certain product lines, and you want to make sure your cost per click on a product line isn't going through the roof when your margins are already really small on that product line. Or if you have larger margins, you can afford like a larger cost per click or cost per paid clicks, that type of thing. And you're going to show all of that in like a visual dashboard, a visual way that a business partner can look at that. And it's usually just a line chart that they can look at it, and they have reference lines on it. So maybe there's like a maximum recommended cost per click limit, and then there's the cost per click like coming up, and you're like touching that limit, and then it's going to like send off an alarm. Right? So dashboards are just a lot of KPIs, not a lot of KPIs, but some KPIs in a visually easy to understand way. And you don't want to overload it either. Like dashboards are really easy to overload with a bunch of information. And then that's another way to get sent to the dashboard graveyard. And it's a place that's really easy to go to and really hard to get out of when you're doing this. So that was a good question. Any other questions, comments? Awesome. Move on. Got it. Type of statistics. 4 different types of statistics. Maybe more, but there's at least these on the slide. And for now, we're only going to think about these ones. So we have descriptive and inferential, right? So really just what's going on. Let's talk about the thing that's going on. How can we begin to understand the thing that's been going on? And that's really where data analysts are thriving, right? That's where it's your wheelhouse. That's what you're working on. You're describing populations. You're describing maybe samples of those populations, and you're talking about what's going on and why it's happening, right? And then you have predictive and prescriptive, which might do and you might not touch it as a data analyst, right? You might have some other things going on, and you might have to go on to a new project, and then you hand it off to the data scientist who's building the model and doing a lot of this work. So again, predictive and prescriptive, right? It's predicting out into the future, and then also trying to understand the reasons why you predicted the thing into the future. So predictive and prescriptive statistics. I'm not the statistics master. I'm not going to claim that. I did have to verify some of this before, but this is definitely splits things up into different areas of work that I've done before, right? Definitely done the data analyst, descriptive and inferential statistics before. Definitely done the prescriptive and predictive statistics before. Y'all probably understand it better than I do, as you've probably learned about it in your classes more recently than I have even. But it's just a level set with everyone here. Any comments, questions? Awesome. So then we're going to run through all 4 different kinds of statistics that were on that chart there. But I really like this kind of high-level look at it, right? So descriptive, just some summaries about the samples and measures, mean, median, mode, variability, distributions, graphical representations such as histograms, pie charts, and bar charts, right? All describing everything, describing what's happening, describing why it's happening. Well, then inferential statistics. So this is where we start to get into those hypothesis testing, estimations, make predictions or inferences from the data. So this is like that borderline. Are we making predictions? Not really, but we're starting to get in that direction. T-test, chi-square test, ANOVA, regression analysis, all these fun things. But then regression analysis borders into, right, we can now start making predictions. So predictive statistics, more advanced analytics, predict future outcomes, regression, time series, machine learning models, XGBoost. XGBoost, the only one you really ever need to know anyway. If anyone tells you need to know something different, you don't. Just XGBoost and be done. Or linear and logistic regression. That's like there's 3. That's it. There's no more. Prescriptive statistics. These analyze data to determine the best course of action. So simulation and optimization algorithms, complex event processing, and recommendation systems. So we start to get in now to like the really deep learning recommendation system, not necessarily deep learning, but things that are really helpful for the business to start to understand, okay, what can we do next? I know at our organization, we rely on some pretty complex models that fall into this category to sell back. So we're like data aggregator, we sell data essentially, and we sell that data back to other companies, right, who use that data. So companies are really leveraging the prescriptive statistics, and right now, even as we go into Gen AI is going to be a whole other thing that people are selling data and selling. So advice for data analysts. After we talk about all these things, right? We talk about why is the data analyst important, different types of statistics, different job roles you might be doing, et cetera, et cetera. Really want to like throw out this one piece of information. And also for the lab, this will be useful. But advice for data analysts, just ask questions, right? This is more important than any technical skill you have, because the technical skill you can learn, the technical skill you can ask ChatGPT to do it for you, and it'll do it for you. But if you don't know what to do, then that's it. Like you're done. Like it's full stop, because you got to know what to do. And so the questions piece of this is huge, and it's not just asking questions, right? But it's active listening. You have to listen to your business partner. You have to listen to what their needs are, and when they say they need one thing, like ask them why 3 times, and then you'll probably get to something else, which is actually what they need. And I didn't do this at first for a long time, even though people always told me to do it. And then I started doing it a little bit more, and it started saving me a lot of time. So even if you can just ask why once or twice to a business partner, and not like just, hey, why? But like, hey, I hear like this is a thing you're mentioning is like a pain point for you. Like would love to learn a little bit more about that. Like how has it become a pain point, or how is it a pain point for you? And framing your questions, active listening. And this is where the soft skills really matter. Being a data analyst is not just the technical skills you have, but it's also your ability to listen And you also have to learn the business, right? You can't, like on day one of being a data analyst in a new industry, be like the best data analyst because you have to learn about the industry. You bring your data knowledge with you. I've changed industries 5 times, so I feel like I'm always starting over in like a new field and like a new industry, and I have to learn all the industry lingo that they're talking about, as well as do the work that's being assigned to me without really knowing what I'm supposed to be doing. And the best way to get over that is just ask questions, right? You hear them complain about something, and you're like, oh, interesting. Like, why is that? Or you hear them say, yeah, I was looking at this and it looked weird. Oh, why did it look weird, right? Actually had a call today with the business partner who was saying, the data looks weird. Actually, this was 3 weeks ago. Or I was asking about like data quality, right? And how to know when we've gone past like an upper or lower limit that we should have on the data. And the business partner says, I don't know, the data looks weird. And I was like, okay, but what does look weird mean? And they go, I don't really know, it just looks weird. And I go, okay. So we scheduled a call out. They went on vacation, so they got back from vacation. We had a call just today, and took an hour of watching the business partner do what they do every day and then saying, hey, this is weird. And I go, okay, great. Why is that weird? Like, we really had to get into like, why is it weird? Like, tell me why it's weird so I can put like numbers around it, and I can start putting some like quantitative thoughts in my head about the data being weird and why is it weird. So it's really it takes a lot of patience, it takes a lot of time, but it's worth it, right? To do your job the best that you can do it, to get to the source of the problem, because at the end of the day, right, you're trying to solve problems, you're trying to make the business money, but it's also just like practicing all these things that you've learned in school and putting all these things into use at work. So it was asking questions, right? Most important thing you can do, ask questions. And probably along those lines is also listen, right? Don't just assume that they're going to say something. Like, actually listen to the words that are coming out of their mouth, and not just like, oh, trend break, or oh, data break. Like, I don't know, like something, just listen. So any thoughts or questions about that? Experiences when not listening came to bite you? Because we've all had that happen. Cool. All right, that's it actually. And then we're gonna move into the lab portion. I am 10 minutes early, so I'll take a couple minute break here if people need to get up, go to the bathroom, get water, do whatever they need to do. Or if you just want to ask questions, have a conversation. This is the last slide for the theoretical portion of this. And in a couple minutes, we'll get started with the hands-on lab. So it'd be a really great time if you're not in the GitHub already, to come up and either talk to me so I can get you in the GitHub so you can pull the code down, or it's in the Git. So ideally you get in the Git. I could email it to you, but really I just prefer you get in the GitHub and you can pull it down from there. So let's take a couple minutes break. I'm going to stop this recording here.